Where's my capture status? Okay. Oh, I see. If I want to move this thing, I have to open this up. I guess I'll put this down here. Okay. Okay. So the thing that we're drawing on is the HTML5 canvas. If you click on this link, you'll see some information about the canvas in native JavaScript, which is if we weren't using P5, we would be writing code that looks like this. It's pretty much the same thing, but P5 just simplifies a lot of that stuff for us. So when we're working with P5, when I hit play here, this is our canvas. It actually creates the canvas for us, so we don't even have to write the HTML. It just creates a little canvas for us, and we can draw on there. So P5 uses the canvas as kind of a metaphor for like painting or drawing. Like if we were drawing with a physical pencil on paper or with paint on a canvas, that's what the canvas is like. It's for us to do a drawing rather than just adding, HTML content to the page. So when we hit play, we get this little canvas, and you can see this line of code here is a function that creates that canvas, right? It's pretty straightforward. So we'll talk about that in a second. You can see that there's a couple numbers here. You might be able to guess what those numbers are doing. If I change one of those numbers, like if I change the second number to 600, you'll see what happens is that the canvas gets bigger, right? So those numbers basically decide how big is the canvas going to be. And the default is 400 by 400, but you can really set it to whatever you want. If I want to make it wider, I'll use the first number. And if I want to make it taller, I'll use the second number. So that's usually how our sort of like positions go, is the first number is going to be the horizontal dimension. The second number is going to be the vertical dimension. So as I mentioned, Canvas is used to draw graphics. You can use it just using regular JavaScript. The reason that we use P5 is because it basically makes a lot of functions that we can use that are simpler than using JavaScript, but they're doing the same thing. So it's like it's as though we wrote a lot of really nice functions on our own and we're using them, except somebody else wrote them. They're just very common functions that a lot of people want to use to do things like draw circles, draw graphics, like make interactions and stuff like that. So it's the library kind of like packages a bunch of stuff together that we want to use. It's based on a program called Processing, which is a Java library, or it's really like a software IDE that uses a lot of the same concepts. So that's where it comes from. It's like 20 years old at this point, Processing, which is kind of crazy, but that's where it comes from. So like I mentioned, P5 is developed with artists in mind, P5 and processing. So it thinks of software and sketches as like drawings, and it uses Sketch as kind of the basis of how we refer to each program. There's other functionalities that we can add in there, like audio and video, and pretty much anything we can do on the web. But that's why like the first file, like the file that it creates is called sketch.js, and we refer to these little programs as sketches. Okay, so we don't have to do this part because we're working in the browser, but I'll just point out, so the reason all this stuff works, if we look at this HTML file here, let me move the console down a little bit. So this is a pretty simple HTML file. You guys have taken MP100, so you've written HTML before. So you recognize like the HTML, the head, body, but everything else in here is literally just loading the P5 library. So this script is referencing an external script that's hosted on Cloudflare, and this is the P5 library. This script is the sound library for P5, and then this is the style. So that's all the HTML that we need. Everything else is just creating the sketch and then us writing the sketch. If we look at the style.css real quick too, literally all this is doing is changing the HTML so there's no margin around the canvas. Like if I take these parts out and run the sketch again, there's just like a barely visible margin, which is the default for a CSS and HTML page. But we don't want that, so we just take it out. So that's the default. That just gets generated as soon as we create a sketch. Okay. Okay, so really quickly, to talk about the way that a P5 sketch works. If you've ever, when you do geometry in school, you're using what's called a Cartesian coordinate system, where 0, 0 is in the middle, and x goes right, and y goes up, and negative x goes to the left, and negative y goes down. You guys remember that at all? Does it look familiar? Okay, cool. In computer graphics, it's changed a little bit, right? Because we're not thinking about like space, we're thinking about the screen. So 0, 0 moves to the top left corner, and x goes this way, and y goes this way, and we can go negative, but then we're going off the screen. So if we want to be like slightly off the screen, we might be like a little bit negative, but the whole screen is positive on x going to the right, and positive on y going down. That's the one that's kind of the hardest to get used to, because if I have like a thing here, and I want to move it down here, I actually have to add y to it instead of, subtracting y. So that's the part, that's flipped. Like, x is the same direction, y is the opposite direction. So you'll see how that works when we start writing our program. So here's our first really simple program, and you guys can type along if you want to. So I'll explain a little bit more about everything else that's happening here, but what you want to do is just put your cursor inside of the draw function and make a new line. And we're just going to draw a circle on the screen. The notes say ellipse, but you can also use circle. They added that to the library. So I can say circle, and I can say, let's just choose some numbers. So I'll say like 300 and 200 and 100. Okay, so now we have a circle on the screen. So any guesses as to what each one of these numbers represents? Yeah. Yeah, that's the right direction. So, so what is 300? What do you guys think 300 represents? No, that's close enough. One of those numbers is for that. So let's change it, and then maybe you'll have some ideas. So I'm gonna go and I'm just gonna change 300 to 400. Okay, so now what do you think it represents? The x-axis. So how far we go this way? Okay, so I'll change it again. I'll just make it 0. Okay, so if it's at 0, it's overlapping with the y-axis, right? So all the way at 0 on the x-axis. And if I make it 600, right? 600 is our width of our canvas. So now we're all the way on the other side. So then what do you think this number is? Right, so it's the y-axis. So if we're 0, we're at the top. And if we're 400, at the bottom. And 200 is right in the middle because it's half of 400. Okay, so let's put it back in the middle. And so then what is this number? How big it is, yeah, how wide it is. So if I make this bigger, it's going to be bigger. And if I make this really big, like 1,000, it's going to take up the whole screen, right? So we don't see the edges. If I make it like 400, it's going to be the same size as the canvas. Or if I make it 600, it's going to be the same width as the canvas. Oh yeah, ellipse. So we can use circle, but we can also, if we want to have an ellipse, which is a circle that has a different width and height, I can do an ellipse that's like wider than it is tall, like that. Or the opposite, I can do taller than it is wide. Something like that. Is that what you're talking about?
Yeah.
Yeah. And that's actually what I have in the notes, ellipse, because circle is actually new. Because if you want to make a circle, you can just make an ellipse with the same width and height, right? So they didn't actually have a separate function for that, but at some point they added it. All right, let's keep going. Okay, so we looked at this stuff. So let's talk for a second about functions. We'll go into more detail about this in the future. I'm going to skip this stuff. Well, actually, okay, we can go over this stuff. Okay, so you can see a couple. So there's not very much in our code yet, right? Except a few things. So the word function, right? So you can see that we use that twice, right? And what a function is basically just like a series of steps that we want our program to do. So one thing that you don't really see that P5 is actually doing for us is this draw loop is running constantly, like a game engine would. Like, you know, if you're playing a video game, you might see in the corner like the frames per second, right? Like you're trying to get up to 60 frames per second to play it fast enough. The same thing is happening right here. We can't tell because we're just drawing the ellipse in one place, but the draw function is actually drawing this 60 frames per second. And the way that we could tell is if we were doing some animation or some interaction. So we'll get into how this works a little bit later, but if I do something simple like swap in the X position for the mouse, now you can see I can actually move the ellipse around on the screen. So I can start to make some animation, some interaction by changing the position, and that's happening because P5 is calling my draw function over and over and over again, like 60 frames per second, so it's painting my sketch, you know, over and over and over again. So we don't actually see that because P5 does it for us, but it has some code that tells it to do that. The other function we have is setup. So you might be able to guess, but this just happens once. So with a function, you have some code, and you can run it once, or you can run it, you know, millions of times. And you can decide how much you want to run it. So the setup function creates our canvas. Okay, so if we didn't do that, we wouldn't have a canvas to paint on. But we only need to do that once, right? Once we have the canvas, we don't need to make it again. So anything we want to do once, we do in setup. Anything we want to be part of our drawing that's changing over time, we do that in draw. The thing that's a little tricky about the way that P5 does this is it has some functions that it calls itself, but if you were writing code from scratch, you would have to call the function. And I'll show you guys how that looks real quick. We're not going to do a lot of this for a couple more weeks, but if I wanted to write my own function, I would write the word function, and then I could call it whatever I want as long as it's just using letters. Okay, so I could call it like banana if I wanted to. I could call it apple. I can call it pretty much anything I want to. I can't do like apple and banana like that with a bunch of spaces, because JavaScript is expecting, once it sees a space, it's expecting something else to happen. Okay, we'll talk more about how functions work, but just as a quick example. So if I want a function called banana, I'm going to have some parentheses at the end of the function. That's how JavaScript knows it's a function, those parentheses. And then the part of my function where I add the code goes in between two brackets. It kind of looks like CSS when you're making a CSS rule. But here I'm defining my code. So what I'm actually going to do is I'm going to print something to the console, which is down here. I'll talk more about what this does in a second, but I'm just going to say console.log. And I'm going to put a little string in here, and I'm going to say banana. And so now when I run my code, nothing happens because I haven't actually called my banana function, right? So the way that I call banana is I actually write the name of the function again, but this time, instead of defining the function with the function keyword and a code block, I just put the name of the function there, and it'll run it. So there we see our banana. So I'm not going to spend a lot of time with this because we're not going to be writing our own functions for a little while, but just so you guys know how these work or what they are, those are our functions. So we have the setup function, we have the draw function. For now, those are P5 functions that it calls for us, so we're just going to use those. We'll add our own functions in a few weeks. So the other thing that you have with functions is arguments. These are things that we can put inside the function to decide how it works. So in the example I have here, so I have a different function called sandwich. And this takes an argument. It's just like, what did I call it? A fruit. Okay, so I'm making a fruit sandwich. So it's a type of fruit. So you can see with our other functions, right, that we have these arguments. Like the create canvas has 600 and 400. Those are the two arguments for the width and the height. Other functions have different arguments that tell it how to act. So our background, we haven't gone over this yet, but this 220 is the color of the background. It represents this gray color, and we'll change that a little bit. For our ellipse, the parameters are the x position, the y position, the width, and the height. Draw and setup don't have parameters because they just do the same thing regardless of what we put in there. So a function doesn't have to have parameters, but most of them do. So if I want to use a parameter, it's basically as soon as I say it's there, I can just use it. I can say console.log. And so now I'm going to say I made a, and we haven't really talked about this yet, but I'll go over it later. Fruit plus sandwich. Okay, so this is a pretty stupid function. It's not that useful, but it's just to demonstrate what an argument does. So I'm going to call my sandwich function. And the first time I'm going to give it the argument banana. And then I'm going to call it again, but I'm going to give it a different argument. This time I'm going to call it apple. So you can see the function did the same thing, but it has a different result. The fruit goes into this little sentence. So that's what my argument does. It changes the result of the function. So with our drawings, most of the arguments that we're going to use are numbers, right? They change where the drawing is and the colors and other things like that. So let's keep going. We're going to get to actually doing stuff with our drawing. Okay, we talked about create canvas. Okay, so we already did this. We already changed the arguments. Okay, so now let's actually add some stuff in here. So we'll talk about a few different things like colors and shapes. So I'm going to take out this code for a second. Let's see. Oh, the other thing actually I want to show you real quick before we get to the next part. So one thing that we can see that's happening is I'm drawing new versions of this circle, but we're drawing this background behind it, so we don't see that we're actually drawing it over and over again. But if I take that background out, now you can see all of the different copies of the circle that I'm drawing, right? So when we're this is like creating an animation. We're not actually moving stuff on the screen. We're drawing something in different places, but it's happening so fast. And since we're covering the background, to us it looks like motion, right? Like we're recreating motion. It's just like an animation. You guys have probably seen, if you took an animation class or the MMP 100 class, you've probably seen that thing with the horse where you see how the horse is running, right? You guys have seen that? I can Google that real quick. I think it's Edward Muybridge. Okay, so he wanted to prove that the horse never touched the ground. Yeah, that there's a point where the horse doesn't touch the ground. And so the way that he proved that is that he set up a camera along the horse track and he took a photo as the horse was running. And that's basically how animation works, except we put all those photos in one place and we watch them, over time, and it looks to us like real motion, but it's really just a sequence of images. So we can see that with P5. if we take out this background and I move my shape around, we can see it's just drawing in different places. But when we put the background back in, now it looks like it's just one shape, right? So combining time with our graphics. And that's like literally how everything on your computer works. The only reason it looks like text and images and shapes and stuff like that is because they're covering up what was there before. All right, so let's go over a few more things. So our next assignment is going to be to make a self-portrait after we finish the first assignment. But I'm going to use a self-portrait now just as a quick example. So I'll stick with my ellipse that I have already for the background of my face. So if I want to build out my self-portrait, I can just start adding to what I have here. So I can make another ellipse. And if I want an eyeball, I could start kind of, there's different ways to kind of approach like making compositions with code. But what I'm going to do first is I'm just going to put an eyeball basically in the same place, but I'm going to make it smaller. So I'm going to say it's 20 pixels. Okay, so there it is. So I probably want it to be a little bit higher. So if I want to go higher, I have to make Y smaller. Remember, Y goes down. So I can move it up there. Maybe that was too far. Do like 125. Wait, what was it originally? Let's try 150. Oh, yeah, right. I have to add. Let's try 175. Okay, that looks pretty good. And then we want to move it over to the side. So I can change this. I can say like 325. But remember, we were doing math on Monday. I can also just do math. Like if I don't want to figure out what that other number should be, I can just say 300 plus 25. And it'll do that math for me. It can figure that out pretty easily. Or if I wanted to do like, times, whatever. Okay, so now I have this second eye, and I can copy this line and paste it. And I'll just put this on the other side, so I'll say minus. Okay, now I have two eyes. Now we're getting somewhere. One thing to note is if I put these eyes above my face shape in the code, they're going to disappear. So it's going to draw things in the order that we put it in the code. So if you want something to be, overlapping or something like that, just keep that in mind. Okay, so let's draw a little mouth. So I'm going to use a rectangle for this, and you're going to notice something a little weird. So I'm going to put a rectangle, and I'm just going to copy my parameters from my face. So if I want to draw a rectangle, I use rect, R-E-C-T. It's obviously short for rectangle. And so I can hit play, and we see our rectangle. So it doesn't look exactly like what we expected, right? It's not centered like our circle, and it goes all the way down the screen. So basically, the rectangle by default, for whatever reason, draws from the top left corner, like our canvas, whereas a circle draws from the middle. So I can either do the math to figure out how do I change that, or I can use a function. So easy way to do it is to use a function. I can say rect mode center, and we'll talk a little bit more about why that looks the way it does later. Or if I don't want to do that, if I want to do some math, I can say, okay, so here's my position. I have to move, if I want it to be centered anyway, I have to move like halfway over here. So this value is 100, so I have to take 50 off of that. So there's different ways to do it with code, and you'll see like we'll look at different approaches, but one way I can do it is just by doing the math. So I can say, okay, what's 300 minus 50? Okay, that looks good. For a mouth, it's too tall, so I'm just going to make this smaller. Let's say like 20. Whoops, that's the Y. Forgot about that. Let's leave that at 200. Okay, so this is actually the y value. I want to move it down a little bit. So let's say it's like 225. Okay, and then the width maybe a little bit smaller, like 50. Okay, but now it's not centered, so now I have to change this, negative 25. Okay, and then it's obviously way too tall, so let's make that shorter. Okay, that's better. So this is kind of tedious. We're going to learn better ways to design things than this, but this is where we're going to start. And then one little thing I can do on the rectangle if I want to add another number. So another thing is that some arguments are required and some aren't. And it's a little confusing because sometimes you'll add an argument and nothing will change because it just ignores it. But sometimes it'll do something. So like if I add a 10 here, then it actually rounds the edges of the rectangle. So that's an optional argument. We'll go over this more, but just so you guys see that, there's some optional stuff here as well. So I've got a pretty basic self-portrait going. Let's talk a little bit more about the code, and then we'll add some colors. Okay, I already mentioned the P5 reference, but just to go back to that. So remember, if I go to help and I go to reference, it'll take me to this reference page, and we've been drawing some different shapes. So if I go to shape and go to ellipse, it's going to explain some information about how this shape works. So it says, here's the syntax. You can see it has an x value. That's what it's expecting for the first argument. Then it has a y value for the second argument. W is short for width, so the width of the shape. And then you can see that h is actually optional. So if we draw an ellipse without an h value, it's just going to fill in the w value for the h value. So we can put h in there, and it'll add it. There's also an optional detail value. This is for a different graphics mode, so it's not going to work where we are now, so we can ignore that. So you can see it says WebGL. We're not in WebGL mode. I don't know if we'll get to that, but I might explain what that means later. So yeah, everything that you can do is somewhere in the reference here. So it's a good thing to reference to go in there, and it's useful for like if you're looking at somebody else's example and you see some code and you don't understand what it means, you can look it up in the reference and it might explain it. It's also just a way that developers learn how to use stuff. So usually when you're learning code, somebody's probably going to teach it to you, like me, or you might look at a YouTube tutorial or something like that. But let's say you were the first person to ever use the library. There's no tutorial, right? So you have to go and read the reference to understand what you can do with the library. Also, at a certain point, you may want to do stuff that I haven't taught you, so you may want to go in the reference and look at what's there. All right, so we've been doing some shapes. We did ellipse and rectangle. And we talked about arguments. We also have arc. What could I do with an arc? I did mention rect mode. Okay, let's do arc, and then we'll go back to rect mode for a second. Okay, so an arc is kind of like an ellipse. Let's go to our reference, except it doesn't go all the way around. So that might be useful for making shapes that aren't fully circle. And you have a few options. You can make it look like kind of a pie. You can cut off this part. You can draw the line all the way around, or you can draw the line through the little pie area. What could I use an arc for on my character? Any ideas what an arc would be useful? Ears? All right, let's see if we can draw an ear with an arc. So I'll put an arc. So again, I'm just going to put in the same numbers so I just can get a reference to where it is. Eventually, we're going to use way more sophisticated ways of doing these designs. But for now, since we're just learning, I'm just going to start with the same numbers and then adjust them. Okay, so it's telling me that's not enough arguments. So sometimes if you write something and it doesn't work, you'll get a little message in the console that's telling you why it doesn't work. So that's useful. There's different types of messages, and we'll go over that next week. So it's saying it needs at least 6 arguments. So we can go back to the reference and say, what is it looking for? And it's looking for the position and the shape but it's also looking for where to start and stop as we're drawing around. And that's actually measured in pi. Do you guys remember pi from doing like trigonometry and stuff? So pi tells you how far around a circle you are. So let's try this. So let's start at 0 and we'll go to pi. So in P5, I can just write out pi with a capital P and I. And I don't really know what just happened. So let's move over because I don't see what's going on. So maybe I'm covering up something. Okay, there it is. So I basically made the same shape as my head, which is not what I want for the ear. But we did move over a little bit, and so we're closer to where our ear could be. So we need to, what do we need to do? We definitely need to make it smaller. So let's make the width and the height smaller. Okay, that's better, but now we have to go back closer. So let's go back to 350. Okay, now we just have to turn it around. So how do I do that? So I need to change the starting point. And let's see. So 0 to pi is like half. So I probably need to start somewhere negative, like negative pi divided by 2, so half of pi. Okay, that looks pretty good. And so then we can just go to pi divided by 2. So a lot of time you will have to use math. Oh, that doesn't look too bad, actually. So we got to use some math to figure out how far we have to go. The arc one is kind of challenging. If you don't get it right away, I wouldn't worry too much about it. It's kind of counterintuitive. Or it's not really counterintuitive. It's just like not a number scale that we use very often. Like linear number scales we use a lot. Or just like 0 to 10, 0 to 100, whatever. Pi, we don't really think about circles and, you know, the angles around circles that often, so it's a little more confusing. Anyway, so let's make the other ear. So I'll just copy this and paste it. And let's see. I got to reverse it, so I'm just going to try to guess if I do this, it'll work, but I don't think that will do it. Oh, it actually did work. Okay. So I just went from pi over 2 to negative pi over 2. And then we just got to move it to the other side. So I'm just going to subtract 100 to 250. Okay, cool. Now we've got some ears. I probably went a little too fast through that one, but don't worry if you didn't get everything. You don't have to make this exact same thing. Okay. Let's finish our shapes, and then we can take a pause and then do some colors. And how are we doing on time? Oh, we've got time. Okay. So we talked about rect mode for a second, and it basically just changes where the rectangle starts from. So I'll probably use it a lot because it's easier if every shape is starting from the same place, right, than having two different ones. But I already did the math. Well, actually, let's just turn it on again. So if I do rect mode as center, now my mouth is going to move over. And so if I want it to be centered again, I can take out that negative 25. And it's a little bit higher up as well, but that's okay. It doesn't look too bad. So yeah, I can change, and I can actually do that with my ellipse as well. There's an ellipse mode too. I tend to change the rectangle more often because for me it's easier to think of things as having a center when I'm designing stuff. But you know, it depends on what you're working on. Okay, so we're gonna look at a different type of shape for a second. And basically the main difference between, so the shapes that we've all seen so far, the ellipse, circle, rectangle, and arc, they all have one thing in common, right? They have a couple things in common. They have a point where they start that may be in the center, and then they have a width and a height, right? So these other set of shapes are defined a little bit differently. Instead of having a point and then a dimension, they just have points, and they will put all the points together to create the shape. Okay, so there's different types of things that we can describe this way. Exactly. Yeah. So the simplest version of that, so I'll put a little comment here and I'll explain what this means later. Shapes with dimensions and shapes, oops, shapes with points. Okay, so the simplest shape with points is what? Simpler. What? A line. Yeah. So I can actually draw a point, but it's literally just a dot, so we're going to skip that one. So a line is 2 points connected by a line. So if I have a line, and let's say I want to create some hair. So I'll draw a line, and I'm just going to copy my dimensions again. But this time, those last two numbers are not relevant anymore, right? Because a line doesn't have a width or a height. A line, we're just going to connect 2 points. So I'm going to start with 300 and 200. That's the first point, the x and the y. This part is a little tricky because we move from thinking about shapes from in one way to another. So the first two numbers are x and y, and the second two numbers are another x and y. There's 2 pairs or 2 points on our canvas that we connect. So we have 300 and 200, and I'm just going to move over a little bit. So I'll say like 350, 250. Okay, so it's not in the right place, but we do see the line, right? So we're making some progress. So we got to move it up. And this is kind of annoying because now I have 4 points that I have to deal with. And it's also a little weird because the x and this x are separate, and then this y and this y are separate. So let's start with the x's. Actually, let's start with the y's, because if we're making hair, we need to go up. So we need to move one up to like 100. And let's actually just move the other one up to 100 and see. Okay, so maybe our character just has one strand of hair. That actually looks kind of funny. But if we want more than that, we can add more lines. If we want it to like go somewhere else, we can do that as well. But I actually kind of like that because it's just going straight across, because both y values are the same thing. So we're just drawing straight across. Okay, so let's take this again. So I'm just going to copy this and paste it. So I'll have another line. I'm just going to move it over a little bit. So I'll move it over on the x like 25. And same thing over here. So 350 plus 25 is 375. Uh-oh. Oh, I only moved the x. I need to move the y as well. So let's move the y down. 125, 125. I think this is going to go off his head. Oh, no, we're still there. But it's a little too far away. What? Say that again? Instead of 325 and then 375, 375 and then 325, oh, actually, okay, so this is a good question. So what'll happen if I swap these two? So right now, we have 325, 125, and 375, 125. What happens if I swap the two x numbers? It's the same thing, right? Because we're just drawing a line between the 2 points. So what I want to do is actually go up, but instead of deleting this one, because I'll probably make another one. Well, actually, I don't want to divide 5, so it's going to be too complicated. All right, so I'm going to change all of my 25s to 10. So I'm going to do 310, 110, 360, and 110. Okay, that looks pretty good. I'll just make a couple more like that. So I'll just go up by 10 each time. And again, this is not how we're going to do everything. This is really tedious. This is not really how you should be writing code, but we're just learning the basics right now. It's kind of weird, like the line thickness seems to change a little bit depending on where it's on the computer, but That's good enough. I could do like divide by 5, but I don't really want to do more than that. So yeah, there's our line. So line connects 2 points. So if we go up from there, the next thing that we're going to have is a triangle, right? 3 points. Okay, so this gets even more complex to write because now we're thinking about 3 points and we're going x, y, x, y, x, y. So we can write triangle, and then we need 3 points. What am I going to draw for my self-portrait that's a triangle? A hat? Okay, like a little triangle hat. So so the middle of our guy is like 300, 200. And let's see. Yeah, triangles are hard to do because you can't think about the width and the height. You have to think about the 3 different points. So let's start. Another thing that you can do that's nice in JavaScript is I can add multiple lines to my code. So one thing I might do when I'm writing something that has a bunch of different data in it is just make a line break. So I can have one XY value like that, and then I can have my next XY value. So if I'm in the middle, let's just put one over here, and let's go up on the Y, and then we'll do the same thing here. So that'll actually draw a triangle for me. Oh, that's not actually so bad. Okay, so the only problem is that it's in front of everything. I want it to be behind stuff. So it's kind of going to mess up my organization a little bit, but well, actually, you know what we can do? Let's just make it his mask. So let's just move it down. So I'll just move everything down. I'll do like 300, 200, 200. Okay, we'll do like 350 and 250, 250. Or it's kind of like a weird, I don't know, bandana or something. And let's make it a little smaller. So instead of, so it's going 100 on both directions. So let's do 350 or 250 and 350. So now he's just like kind of an ice cream cone, I guess. Let's make this a little less tall. Okay, so now that kind of looks a little bit like a mask. We could draw some lines going up to his ears. Anyway, that's a triangle. It's kind of a pain to write. I don't really use them all that much, but we'll leave it there. Another thing that I can do is I can actually put, well, I haven't talked about comments yet, but I can put comments like this if I want. So xy1, xy2, xy3. So I can visualize the points. What? Yeah, it's kind of hard, but it's one thing that I would do to visualize that is just draw a circle at each point. So I can just like copy the xy for this one if I want to see where it is. So I can take those 2 numbers, copy, and just draw a small circle there. Okay, so that first one is actually the bottom. So 300 is like in the middle on X, and then 300Y is like a little bit farther down. And so then I could make circles for each one of those points if I want to visualize it. Okay. So then we also have one more before we get to comments is the quad. And this is just like another point, right? If we do quad, now we're going to have 4 points. I don't know what else we want to draw. I'll just draw like a little shape in the background. So I'll do like 100, 100. And let's say like 500, 100. I'm going to change these a little bit. And then let's say 500, 300, and oh, I already did the 300. So a quad is like a rectangle, but the nice thing about that is it doesn't have to. Oh, I flipped my my shapes a little bit. It's also going to be in the front. Okay, this is going to be his bow tie. Let's just move it down a little bit. So we have to move all of these values down. The reason it's flipped is because of the order I did the shapes in. If I wanted it to be right, so it's going. This is actually kind of confusing. So it's going 100, 100, then 100, 300, and then 500, 100, 500. That's why it's flipped. So it's kind of confusing. It's probably not the best example to start with, but let's just flip these. And now it's just a rectangle, but I can move different parts of it. So like if I add 50 there, goes down a little bit. If I add 50 here, goes down the same amount. I can move those points around. So it's not just a rectangle, I can add angles to it. I'm just going to take this out though and just say quad. Okay. So the last thing to mention is our, for this part, is the comments. So I've already written a bunch of comments, but I want to talk about what they are for a second. So a comment is basically part of your code that gets ignored by the browser, and we can use it to make notes in our code. So like when I wrote shapes with dimensions, I was like making a note to say these next bunch of shapes are shapes that have a point and then they have a width and a height. Then I wrote shapes with points to make a new section where I'm talking about shapes that have points. So those comments don't actually change the code, but they're useful. If somebody comes and reads this later, they'll understand, oh, I see this, we're dividing between these two different types of shapes. So you can explain different things that are happening in your code. And this is really important for a lot of reasons. But the main two reasons are if you're working with somebody else. So most of the time when you're writing code, you're going to be working with other people. Typically, any software project is going to be a big project. There's going to be a lot of different developers. And so you use comments to explain what you're doing, because you can read through this code and you might be able to guess what it is. But if I just showed you this code without the image next to it, would you be able to say, oh, that looks like a person's face? Probably not, unless you are really good at visualizing stuff. You would just be like, it's a bunch of circles. You might be able to guess at somebody's face, but you can't tell that unless you see the result. So what we want to do is use comments to say something like, self-portrait. I'll say version 1. So that way, when somebody comes to read this code, they'll immediately know why does this code, what's the point of this code, right? The other thing is it's actually just useful for yourself to make comments to explain what you're doing, because you'll write a bunch of code, then you get busy, do your other homework, come back like a few days later, and you'll be like, what was I doing? Like, this doesn't make any sense. So that's another reason to write good comments. So you can write a comment by putting 2 slashes, and then you can write whatever you want after it. You can also do it after a line of code like I did here. So if I wanted to, add some comments here, I could say like, this is the face. This is the right eye. That's really useful. There's no way for me to really know that otherwise. This is the left eye. So if I go back and edit this later, I don't have to dig through my code being like, what's going on? I can just immediately say, oh, okay, I see what this is. This is the mouth. This is the right ear. And this is the left ear. Another thing that is useful with comments actually is that you can remove code for a second and then bring it back really quickly. So I may say, you know, I want to see what this looks like without the face, but I don't want to delete the code because then I might forget what it said. I can put a comment in front of this line of code and then run it. And now the face is gone. So I can see what changed, and then I can bring it right back and see that it's, you know, see what it looks like. So that's actually a third good use for comments is when I do that, I call it commenting out the code. Let's see. Another thing that I can do with comments is I can actually write a multi-line comment. So with the 2 slashes, if I hit enter and start writing stuff, like, you know, by Owen Roberts or whatever, this is going to give me an error because it's not part of that comment anymore. So I'm going to get this error. But if I want to write comments that take up more space, what I can do instead is put a little asterisk here. And now you can see my whole program is commented out. So once I start that slash with the asterisk, I need to end it. So I need to put another asterisk and another slash. And now I can write as many lines as I want to, you know, as long as I end that comment eventually. So I'll put a little enter here, a little one here.